Welcome everyone, and this is our third SWAN Insight as a Service Partner webinar. And this time, can you all hear me well? I think, yeah. So at this time, we are actually partnering with Qatium and featuring Leeton Shire Council Australia. For those who don't know me, my name is Gayatri, and it's a pleasure to welcome you all for this call. And I'm the SWAN APAC Manager. And for this webinar purpose, this is a recorded webinar and slides will be provided afterwards. Please use the Q&A section of this webinar for asking any questions, and we will try our best to answer as much as we can. So with that, I'm going to kickstart this brief introduction. Next slide, please. So for those who are new to SWAN, SWAN is a global not-for-profit organization. It empowers entire water sector to collaboratively unlock the value of digital transformation. So Insight as a Service is an initiative focused on co-creation of our of topics with our global members, and we ensure diverse smart water topics are discussed with different perspectives. So in this phase, we are actually focusing on webinars, but we are going to expand to workshops as well, based on the industry demands. And so we want to thank Qatium for partnering with us on this edition. I'll also post a link about this service soon. Next slide. So I just want to mention, before I introduce today's speakers, a quick reminder of our fourth SWAN APAC workshop. And that's actually taking place in Sydney this year in November, partnering with Sydney Water. So at this stage, we are in the call for abstract stage. So, and the deadline is 18th of July. So please submit your presentation, your abstract for presentation consideration. And I now go to introducing speaker. The first speaker is Jared. Jared Sims is a manager of IT/OT information and technology at Leeton Shire. So welcome, Jared. He's responsible for IT/OT strategy across the organization, and he's passionate about leveraging digital technology in water to boost efficiency and enhance customer service. Welcome again. And the second presenter is Nicolia. Nico is a senior hydraulic engineer at Qatium. His background is civil engineering, and he has led hydraulic modeling project for major utilities like Thames Water, Scottish Water during his tenure with Atkins. His expertise lies in integrating engineering principles with digital solutions. And with that, I'm now handing the mic to Nico and to facilitate this call. Thank you.
Hi, everyone. Thank you, Gayatri. Thanks, everyone, for joining. So over today's webinar, we will follow the journey of Leeton Shire Water to see how a small utility in Australia has leaped from using a standard GIS dataset to a digital twin in their regular operations. And as a result, this utility has been able to leverage these digital technologies to make smarter and faster decisions. Also, towards the end of the webinar, we will see a quick live demo of a digital twin in action. As Gayatri mentioned, if you have any questions, post them in the question box, and we will try to address them at the end of the session. To start, just to mention that utilities of all sizes experience many challenges and barriers nowadays in achieving good performance, efficiency, and resilience in a water network. However, these are more pronounced in small and very small utilities, which have comparatively less financial and human resources. Now, digital tools can help level that playing field, and Leeton proves that you can start with what you've got, showing that small budget doesn't necessarily mean small ambitions. One of the barriers is the technology itself, actually, which, even though available, this is not easily accessible, mainly due to lack of experience in digital tools within utilities itself. As well, there's a cost component because large software have big upfront costs, so it can be unaffordable for small utilities. You find staff resources are often lacking, and these lacking resources translates into lesser time to proactively optimize network performance, efficiency, and resilience. In terms of performance, we know utility needs to maintain the right pressure and right water quality at all times. In this case, digital gives small teams the same situational awareness that big utilities would take for granted. When it comes to efficiency, the main goal is to reduce non-revenue water, which in turn reduces general workload and also the energy required to deliver water to our customers, of course. Here, digital can contribute greatly since an improvement to network performance reduces operating costs. It also allows the staff to take a more proactive rather than a reactive approach in the daily operations. And lastly, from a resilience perspective, digital tools enable forecasting capabilities. Therefore, we can anticipate to any future demands. So, say, due to weather events, for example, and be better prepared. And of course, it's not limited to only this. Digitalized utility also provides organizational resilience because it does well at capturing hard-won knowledge and the experience of staff. So Leeton ticked all those barriers and challenges, but also had the motivation to achieving a better network performance, efficiency, and resilience. In a few minutes, we will see how they flip the script. So quickly, at a very high level, we have outlined the different stages in a digital journey. At every step of this journey, you can already get value. So you can already take advantage of certain available tools and functionalities. Your journey generally starts leveraging GIS data, as most utilities, even small ones, would have a GIS data set. Unless you have a hydraulic model, then that's even easier to start, of course. Starting with GIS, then you can fairly easily create a digital replica. At this point, this already makes a big leap because you're moving already from a static data set to a dynamic kind of like replica of your network. Here you can start assessing, for instance, the impact of different scenarios, etc. The next step would be to integrate real-time data. So SCADA, any AMI or any IoT type of data you may have. Now you will have a real-time digital shadow, which allows you to basically see things or understand the network as things happen. Once you've got the digital shadow, you can start applying different tools and configurations. So making this now a digital twin, which should allow you to make faster decisions. Here we can really take advantage of most tools. For example, we could set up alerts or warnings on network pressure and flows to get insights into any potential anomalies happening in the network. Since you have kind of like all the bells and whistles connected, we're enhancing network management, a more streamlined and effective operation, and it's pretty much everything in one place. And then as a final step, we can finally incorporate added intelligence. We can start taking advantage of AI and generative AI tools for like that deeper analysis and better problem resolution. Again, for any of these stages in this digital journey, you don't need any modeling experience. And at every step of the journey, you can obtain a readily accessible, let's say, and easy to use digital twin, which should enable any network stakeholder operator to make smarter and faster decisions. And of course, provide smarter and faster response. Now, let's drop into the real world with Jared. And yeah, let's see how Jared has progressed in their digital journey.
Thanks, Nico. So I'll just give you a bit of background on Leeton, where we are. So Leeton Shire Council is one of the most innovative, inclusive, culturally diverse and progressive places in regional Australia. Leeton Shire Council is located in southwest New South Wales, 550 kilometres from Sydney, 500 kilometres from Melbourne. Leeton is the birthplace of the Murrumbidgee irrigation area and is purposely built as part of the Murrumbidgee irrigation scheme. Our water is fed from the big dams up in the Snowy Mountains. Leeton is part of the Western Riverina economy, which is booming, where we gross $2.4 billion worth of gross regional product, with industries based in agriculture processing, agriculture, education, research, transport, logistics. There's 135,000 hectares of irrigated crops ranging from cotton, rice, walnuts, wine grapes, almonds, wheat, citrus, and now even a booming aquaculture industry with Murray cod. All of which you can see featured on our water tower here at night, as displayed as digital projection art. Basically, our region is our region in town is a food bowl. We put the food and drink on your table and the clothes on your back. So we're a high production area. Leeton Shire Council as an organisation has 130 staff. We cover an area of 1,100 square kilometres. We've got 200 odd kilometres of water supply lines and valves covering Leeton, Whitten, Yanco, and the villages of Murrumai and Wamoon. We have 5 service reservoirs. We have 3 schemes across Leeton, Whitten, and Murrumai. Leeton has approximately 4,200 water-connected properties, delivering about 2.7 gigalitres an annum. Smart meters have been installed to support water loss and efficiency programs. We also have a very secure water supply from Murrumbidgee Irrigation, so we're very blessed in that way. So we don't need to shandy the water through any holding dams. We take directly from the irrigation channels that supply the farmers. Thanks, Nico. So the challenges that we face as a small organisation, we have very limited engineering capacity. Often we'll only have one water engineer in the council. We have a heavy reliance on reactive and proactive workload. We have a heavy reliance on contractors. We often depend on external consultants for specialised design or compliance assessment, which introduces a lot of cost and delays especially into projects. We have difficulty attracting and retaining skilled staff. Leeton's regional location, while great for my 2-minute commute to work, is difficult for us to compete with metro councils and the private sector for attracting skilled water engineers, operators, and other people in technology. As such, from having such a small team, when they do leave, it leaves a big hole in the organisation. We lose a lot of specialised knowledge from a small number of staff holding critical operational knowledge about network maintenance, plant operations, and response procedures. When one of these individual leaves or is unavailable, service continuity can be at risk. We have training gaps. We try and use cross-training, but this is a challenge as well. And there's time to take new staff up to skill. We have seen that even temporary absences can stretch our team thin, and coverage often requires calling on contractors or deferring less urgent work, both of which comes at a cost. So there's some challenges in being in a small organisation and some advantages as well. Thanks, Nico. So to increase our water efficiencies and to improve our service level to our customers, we implemented Taggle smart metering in 2020. 99% of the meters are covered by Taggle, with data feeding back hourly. We use the Aqualis software system from Taggle behind the meter to provide leak and consumption alerts, as well as district metering dashboards to us internally. Customers can access their personal water dashboards via a MyH2O portal and control their notifications. This has improved our customer engagement, with 500 properties registered on the portal and 4,200 of those properties in the last 12 months. We've had 7,200 engagements with our customers automatically without a human needing to touch it. To support the digital twin, we've deployed Taggle Cockatoo pressure sensors throughout the network to help correct the model. We've then deployed Cockatoo RTUs onto Chrome mag flow meters to measure interconnects between DMAs to improve the model accuracy. We then installed Taggle AMR network supply meters at all the reservoirs. All this data feeds into the digital twin to help increase its accuracy. Thanks, Nico. In partnership with Taggle, we've also been working on integrating our AMR and SCADA into Qatium. So data from Taggle AMR connected network supply meters is fed into ClearSCADA. We then integrate this data from ClearSCADA from reservoir level sensors, treatment plant output meters, which gives us the supply to the model directly from ClearSCADA via a web API to the Taggle Aqualis IoT platform. We then combined all of that with smart meter AMR data that gives us the customer demand, which we pass to Qatium. So we take all of this data, hourly data across 4,200 meters, and we feed it all into Qatium. We feed all of the pressure sensors into Qatium, which gives us a real good indication of what the health of our network is doing. So it's pretty cool. Next slide, please. Okay.
Thank you, Jared. And that's very interesting. So a question raises, how do you start with the digital platform? You can start basically as small as you want and build over time with no great efforts, to be honest. Most utilities will have some GIS data, which is basically the bare bones of the digital twin, and also some sort of SCADA data, especially on the main assets like tags and big bulk flow meters. Now, none of those have to be perfect, and that should be more than sufficient to start with. Ultimately, what matters is to bring all these together so they can talk to each other and you can make the most of it and get value. If you have AMI data, even better, of course. You can get added insights, but definitely not mandatory to take advantage of the tools and capabilities of a digital twin. You start by drag and dropping these layers of information to Qatium. Then you have all sorts of automated tools and AI in the background that will generate a digital replica. These processes basically automatically connect all the information and resolve any potential issues and data gaps it may find. You then also set up a real-time data feed with our support if needed, so that should be fairly easy as well. Then, if necessary, with some additional input of operational knowledge from the network staff, of course, and on the client's end, you could get a digital twin which is pretty much ready to use and can provide values pretty much straight away. Now, and then once you've got your digital twin, of course, you can start managing your network and your network assets, easily create and assess any operational scenarios, or in general, just help optimize the network. The whole process is very accessible. You've got a browser-based application, so it doesn't need any installation on your desktop. It's frictionless, and it's additionally it's agnostic to any other data platforms or especially sensor data platforms. Secure and most importantly, it's very intuitive, so which makes it really, really easy to use. Here, I've just outlined a few of the most relevant, most common use cases that the digital twin can help with, but of course, there are many, many others. We're going to do a live demonstration, actually, just next of water main shutdown, just to see how we can get insights into this type of exercise and guidance. If we've got time, we can do a flushing exercise as well. Jared will also offer his insights into these two common exercises before and after Qatium as well. But yeah, aside from those from those tools, there's plenty of other use cases. You can help identify, understand, and minimize your non-revenue water and potential mitigation measures that you need to apply. You can monitor water quality, also identify stagnant water in your network, or anything that might need mitigation measures like flushing or maybe network reconfiguration. You can also better understand your demand, or if you need to add any extra demand in the form of a new development, for instance, in your network, that you can basically double check compliance with fire flow capacities and so on. So yeah, let's move on to seeing the platform live. I'm gonna stop sharing this screen for a second.
So while you're doing that, Nico, so I'll just speak about how we used to do our water main shutdowns, which Nico's going to show. It was pretty chaotic, to be honest. It was basically we'd had to go out and find out which valves we thought were in the area and just start turning stuff off. It was hit and miss. But you can see with this tool that Nico's going to show, it's transformative for our operational staff to actually be able to test what's going to happen in a digital world before we start going and turning off customers' supplies.
Yes. As you can see, so basically this is a digital twin in action. It's of a network as well in Australia, so-called, and now has become famously known, Magnetic Island. The platform is really streamlined. You've got very few functionalities, but it's really, really intuitive to use. You've got here on the side your work modes, which help you select the visualization and tools that you want to use. For instance, for the shutdown mode, we get the shutdown plugin or the shutdown tool enabled, and we can straight away perform a shutdown exercise. So say that you get a call and you get notified that the pipe has burst, and you need to close that pipe to carry on any repair work. So I've chosen this one just because it provides quite interesting insights. You would basically just need to select the pipe that you have identified. You need to close up and tell the tool to close it up. And the tool will start giving you guidance of how to close the pipe and insights into the pipe shutdown. As you can see, straight away, the tool has kind of like traced the network and calculated and identified the area affected here in yellow. Also, if you zoom in into the affected area, into the pipe burst, you can see that it has identified any valves that need closed to be able to shut this section. In the panel on the right, you can get insights into critical sites, such as hospital or any other like power plants, anything that may be impacted. This is a simple network. It's an null, so I don't think it has any critical sites. In terms of isolation valves, so as I mentioned, you also get the list here where you can see what needs closed. You can locate it, and also if that valve is because of any reason it's inoperable, say because there's a car parked on it, you can tell the tool, hey, actually can't operate that valve. So you need to find the next available one. The tool automatically gives you insights into, hey, this is your next valve we will need to operate to shut down this section. If you scroll down further into the tool, into this panel, you can also see a number of alternative supply valves that will enable you to get this affected area resupplied. Now, the reason there's two different colors is this is the pipe you need to shut down, and you won't be able to resupply these properties because, of course, you're carrying out repair works on it. However, this other affected or collaterally affected area, you can assess, locate these valves. If you click on the other side of the closed valve, let's say, you can check through these panels whether you've got sufficient pressure on the other side and whether that's suitable as an alternative supply for this area. That looks slightly high, 85 meters, but I can check the other two and see what's happening on the other side, 71. This seems to be closer to the pressure that was supplied to that area and slightly lower. So you can tell the tool, hey, let's resupply the area through this other boundary valve, get supply from a neighboring zone, basically. The tool automatically reassesses the situation. You can now see that we have reestablished supply to the collaterally affected area. Additionally, it gives you insights. So you only have 3 customers that are actually impacted by shutting down your section. And you can also get and download a report with our critical sites. The report is in text format, which is really comprehensive. You can see here, I'm zooming there. You get the summary of the affected customers, also a list of valves that you need to close to perform the shutdown, valves that you need to open to reestablish supply if you have any alternative supply options, valves that are broken, and the full list of customer points and the hydrants that will be affected by the shutdown. So yeah, that's basically it. If you have any questions, please post in the chat box. I'll stop sharing, go back to the presentation now.
Thanks, Nico. So, yeah.
Sorry, Gerard. Nico, there is a question for you in the chat. from Lance as well.
So how long did it take to get set up from scratch to be fully operational? Probably about 2 months. 2 months was by the time we submitted all of our GIS data and then had it all modelled. It was probably about 2 months.
Yeah. Did this include any time that you guys dedicated to the installation of any equipment, Jared, or just on our side?
Yeah, so we had to go and put pressure sensors on and get all those going. So it was a little bit of time for that.
There's another question. How long did it? Next one. Does your shutdown recommend which hydrants to open, which to close, depending on pressure? Which valves you mean, or which hydrants for the shutdown exercise? So it provides you a list of alternative resupply options. So it gives you a list of valves to be able to resupply your area. In terms of hydrants, it highlights the ones that are impacted. So in case you need to notify fire emergency services that those hydrants are not operable during the repair works. Oh, yeah. Okay. Good point. Yes. It doesn't yet recommend you any hydrants. But that's great feedback. We'll take that. I will make a note.
All right. I might keep on cracking on. So flushing is one of the other use cases that we find is really useful for the model. So we've improved the water quality in Leeton by combining out the water age tool in Qatium and the flushing tool. This lets us pinpoint where older water is sitting in the system, design smarter flushing plans that clean the pipes effectively without stirring up sediments, and use just enough water to do the job, minimising water loss and while keeping quality high. It's especially useful in areas with low flow or a long pipeline. The water age tool also helps us to decide where to place chloroclam monitors. We've deployed a couple of chloroclams throughout the network to monitor what the real life chlorine levels are in the pipes. It helps us act early if they start to drop. A great example of this is an integrated approach where you can see in this image is 150 mil main on a 4 kilometre dead end. We have an automatic flushing station at the end of it, which reads from the chlorine readings. We use the hydraulic model to fine tune how the valve opens, balancing the water turnover with the risk of stirring up biofilm and sediment. Thanks, Nick. Okay. We've seen big drops in water loss from 45% in our original non-revenue IWCM down to 15%. Most of this is due to replacing our aging meter fleet, but our digital twin helps take that drive that number down even further. It's helped us actively track non-revenue water by supporting mass balancing, comparing what we put into the system versus what we have actually consumed. Because it's fed by live SCADA and by AMI and Taggle data, we can spot discrepancies, pinpoint leak zones. We're not just finding leaks, we're prioritising field investigations in areas which require additional flushing, reducing the guesswork for our network shutdowns and making smarter decisions. It's been a huge step up in efficiencies and confidence in our network and performance, and delivering better operations and customer service to our community. We're planning on expanding the Qatium hydraulic model to include the villages of Witten and Murrumai. As part of this enhancement, we'll install a number of pressure sensors throughout each village to monitor local level performance. And we'll, instead of installing extra meters, we're going to pull the flow meters directly from the filtration plants and connect them to SCADA. They're already connected to SCADA and pull them into Qatium. So in addition to this, we'll further segment as a couple of the zones in Leeton, in the main town, by introducing more district meters, incorporating our raw network zone into there as well, so we can track what our losses are on our raw network zone, not just on our filtered water. This will hopefully support more granulated monitoring in the network and improving our ability to detect anomalies and localise issues and be more proactive with our infrastructure.
Sure. The following on the flushing exercise, I had a question that popped to mind. How would you do that exercise before using Qatium?
It's pretty wasteful. The guys go out to each endpoint of the network, put a standpipe in, turn it on full ball until the water runs clean. Like there was very little science behind it. They just whack the standpipe on and whack it on full ball until the water runs clean. It was wasteful. It was potentially delivering dirty water to our customers that stirred up between the network.
You wouldn't use any turbidity monitors or any sort of device to assess the velocity in your pipes?
No, it was pretty old school.
Cool. You also mentioned, I think, that you guys installed chlorine monitors at some point.
Yeah.
Would those? Yeah, go on. Sorry.
So we've got 2 chlorine monitors at the edges of the network, and the Qatium tools helped us select the best or worst spots in the network to put them. So, yeah. So
okay. Would the chlorine monitors validate what Qatium?
yeah,
was expecting? Yeah.
They're pretty much validating that. Yeah, there is pretty low chlorine in those areas. They were the reddest of the red in Qatium, and they're pretty low in those areas.
That's great. I think not sure what we've got. Do we have time for a flushing exercise? Could do a quick one. And then we can take up some more questions. Okay, so going back to Qatium, as you can see here, well, I'm coming back from the previous exercise. So as you can see here, a scenario was triggered when I realized that when I carried out the previous exercise, which I can basically just delete and restart over. A general kind of like flushing exercise could be performed generally at dead ends of the network, but also throughout. I'll do a quick one here on these kind of like loop mains, which have a reasonable complexity. Let me just remove. I'm going to remove customer points and outros because I'm not that interested in seeing those at the moment. I can select the flushing work mode. Oh, actually, and that enabled the customer points again. There you go. So say we need to flush this part of the network because we have been notified there's poor quality. And we could start by basically just applying a demand to a hydrant and simulate that water flushing out of the network. It starts small and go iterating. The plugin, what it does, the functionality, what it does, basically tells you, advises you of discoloration risk in yellow and also in green. Once the pipe has reached the optimal flushing velocity, it will turn green. You can also at the same time assess your pressures in the network just to ensure that you're still that your customers are still receiving the correct pressure service level. The plugin also tells you at that point your residual pressure as well. So that has to be, if you have a minimum, that can guide you to ensure you comply with that. You continue to increase your flow until you reach that kind of like optimal velocity in the network. If you see you get to a point that the pressure drops too much, you can start considering closing valves around to limit the capacity and ensure that a higher velocity is increased along the main you want to flush. So say, for instance, here, we could potentially close that valve there and see the result of it. We see that we're achieving flushing velocities here and here. Another option would be maybe closing that branch. Again, limiting that extra capacity that goes through the network. We see we still have this coloration risk around these areas. So we can pretty much focus on, as these are kind of like parallel main that split the demand and the flow through the network. We can close either one at the top or the bottom one. Currently, all these pipes or all these loop pipes have an optimal velocity. However, the pressure has dropped slightly where we apply the demand. So what we can do is we can try to see what is our velocity is 1.9 meters per second. So that's actually reasonably high. We could actually drop the flow slightly just to make sure our pressures don't drop below the service level required. So once you get, say, 18 is reasonable for you, or say you want to look for 20, once that's reasonable for you, let's see, 11.5, just to get to a breaking point, ensure those velocities are 1.5 or more. Demo effect. Okay, so there you go. So you're flushing correctly all these, but you might need to close off this parallel main here as well. So for instance, that would be one of your first sequences to be able to flush that loop. You can iterate and then probably close this other branch to be able to flush the middle one, and so on. You want to reset your scenario, you can start from the beginning again, removing your scenario and then starting over. We can see the pressures have returned back to the original pressures in the base scenario. So do we have any questions about this?
Yeah, it's
So
down.
Yeah, actually, so from Dan Lavelle, one of the features I love about Qatium is the flow direction graphics. When a pipe shutdown is undertaken, a flush is planned or water is rerouted. Can the flow direction graphics change to show the flow reverse or water velocity increases, therefore highlighting newly introduced areas of water quality risk, not just within the planned flushing activity, but also within the upstream network? Yes, so actually, currently the plugin, what it does, it highlights all the pipes in the network that are at risk of discoloration, actually, which includes also reversal in flows, and also any flows above, I think there's a certain threshold, which I can't remember just now. But yeah, it does currently do what you're asking. There's a previous question from Time Palm. Is Qatium capable of continuously updating hydraulic model using pressure and flow sensors to simulate the water supply network in real time, even at not monitored locations? Yes, so basically the platform leverages all the sensor data, and it also takes advantage of this sensor data to continuously adjust the model, like you said. Of course, anything downstream that pressure data, if you don't have additional pressure sensor, there is where the hydraulic model takes charge, because that is part of the kind of like simulated characteristics of the network. So you should be able to still get reasonable insights and reasonable results, even if you don't have sensor data. Yeah.
which is what we do, Nico. We have our tank levels, and then we measure the head pressure from the induced levels of our towers, because we're a gravity network. So it's essentially what we do. The pressure sensors are just there to correct the edges of the network.
Yep. Additionally, if you have sensors for the statuses of pumps, valves, or any other type of kind of like operational asset, those sensors are taken also advantage of and modulating the live model as we receive the data. Yeah. Did you have any further questions?
There are some questions in the QA box, Gayatri, if you don't mind reading on behalf of the attendees.
Sure. So it's from Lance. Do you use hydraulic modeling software in your work? If yes, which one? There's one from Puranet. Pun.
Sorry, can you repeat that question, Gayatri?
Do you use hydraulic modeling software in your work? If yes, which one? Is from Lance.
Yeah, so actually the hydraulic software in the background here, it's a Ethernet engine.
And this the other one is from Puranet. And how long did it take to reduce the non-revenue water from 45% to 15%? It's from Pun.
Yeah. That's probably directed towards me, Gayatri. So that was about 12 months, probably 24 months to get down non-revenue water down from that. Most of it was due to our aging meter fleet. So when we replaced 90% of our meters, that was a lot of the non-revenue water was there. But then we've had some partnerships with the Department of Water in New South Wales, who's helped us come out and do some more fine tuning to try and find which zones are the leakiest.
And I don't know whether you have seen this question from David Brook. How hard was it for operators to learn to use the system? How has it helped the challenges you mentioned about your people? It's a good one.
So the operators have taken to it pretty well. Plumbers are good at lifting heavy things, and then the technology sometimes is a bit scary for them. And they've been really good. We had an incident about 12 months ago where we had a big main break. The guys were trying to do it under pressure. It was an abandoned main that shouldn't have been charged. And Qatium came to the rescue. And when we turned off about 13, 14 valves, we were able to isolate this big main that they were trying to fix under pressure. We ended up fixing that main by turning off about 13 valves that Qatium was able to help us identify, and they wouldn't have been able to fix that problem without a good hydraulic model, and that really proved the point to the operational staff the value of the digital twin.
Excellent. I think we should give just 1 more minute for any further question before we close this webinar. Is there in chat group or in Q&A? I'm just waiting to see something popping up. Yeah.
Yeah, definitely.
May I have Nico's contact information? Yeah. Definitely. So what I've also posted is a webinar feedback form, which you participants can use and submit their valuable feedback about how they found what interesting things they found in this webinar, and yeah, and anything else. And I would also like to take this moment to thank Jared from Leeton Shire and Nico from KDM and all the attendees who attended this call. It's around 5 to 6 p.m., which is a late evening call here in Australia. So thank you all for taking your evening time, which is valuable time, and attending it. And I look forward to presenting more such webinars. And there's a thumbs up as well.
Thank you all very much.
I might end this event and chat to you all later.
Thank you, everyone.
Thank you. Take care.
Thanks, Jared. Thanks, Gayatri.
Thanks, Nico.